Plus, this is part two for the exam review. Now, in this case, we are looking at continuous and smooth. Basically, it means that this expression has to be differentiable. That means when we take the derivative, left side derivative, which would have been this one, has to be equal to the right side of derivative, which would be equal to this one. So let's try looking. So then, limit of f of x plus h minus f of x for h now as h approaches 0. Now, in this case, if x equals 1/2, and then as we know that in order for the limit to exist, what we end up getting is this limit of, by plugging in 1/2, we realize 1/2 plus h minus f of 1/2 all over h as h approaches 0 from the right side. Now here, this portion would have been equal to right here, because the fact that h is positive, then we are looking at the values that are a little bit greater than 1/2, which means we are looking at this portion, and then derivative of that would be equal to a. On the other hand, what if we have the same thing? I'm trying to be, I guess, a little bit lazy. Now, what if we are looking at approaching from the left side? Here, then we end up getting derivative of this expression. We know this one to be negative 1 over x squared. That becomes our derivative. Now, in this particular case, 1/2 has to be plugged in. In other words, negative 1 over 1/2 squared. We know this one to be equal to negative 4. That means simply a has to be equal to negative 4. Now, that was just so that we could have the same slope, but it has to be continuous. That means the values that we get from the left and right side has to be equal to each other. That means the limit of the function f of x as x approaches 1/2 from the right has to be equal to limit of the same function as x approaches negative 1/2 from the left side. Both of those values has to be equal to each other. Now, that means the fact that x is a little bit greater than 1/2, we are looking for this expression. Since a is equal to negative 4, this now becomes negative 4 times x, which is 1/2 plus b. On the other hand, here we end up getting, looking into upper expression, we end up getting 1 over 1/2, which would be in fact equal to 2. When you simplify this one, we will end up getting something like this. On the left side, we have negative 2 plus b is equal to 2. Hence, b will be equal to 4. There it goes. B has to be equal to 4, and a has to be equal to negative 4. That becomes our final answer. Now, this is the second to the last question, but since we finished the last question in class, I will not be going over them online, but let us try to look into number 11 here together. So we have the particle's movement is given in this way. Now, find v of t. V of t here is simply the derivative of s, meaning derivative of sine becomes cosine of ln of t. Now, and then we gotta multiply by the derivative of inside, which is equal to 1 over t. Now, How about acceleration? That is simply the double derivative of this. In other words, whatever we got here, we just have to take the derivative of that. And one way which we can do is, let's keep cosine, okay? Cosine of ln of t times the derivative of this, which ends up being negative 1 over t squared minus. Actually, in this case, it will be plus. But we will end up getting negative sign anyway. So we have 1 over t times the derivative of this one, which will be equal to negative sine of ln of t times 1 over t by the chain once again. Now when you simplify this one, we end up getting negative. Since negative 1 over t squared is common in both of them, when you factor that out, we end up getting cosine of ln of t plus sine of ln of t. Alright, that becomes our acceleration. Now, I wanted you to sketch this one. You can just try to sketch this one using your graphing calculator in the radian mode, so I will skip number B. Let us go for number C. Find t when the particle is first at rest. That means we need to find the at rest means v of t has to be equal to 0. In other words, cosine of ln of t times 1 over t has to be equal to 0. Now, since this portion will never be equal to 0, only way that's possible is when cosine is equal to 0. When do we realize cosine is in fact equal to 0? Cosine can be equal to 0 among many values, but as you can see, the ln of t can be technically pi over 2, or in fact it can be also negative pi over 2. Since as t is greater than 0, we realize that when t is very, very small value, less than 1, it is possible for this value to be equal to this. So therefore, cosine of ln of t has to be equal to negative pi over 2. In fact, there are infinitely many values, but we'll just approach this one. I guess I made a small mistake in terms of question here. I should have made t to be greater than e, then it would have been a whole lot better for us to calculate. But in this case, greater than 1, rather, then it would have been a whole lot better for us to calculate. But since I made t to be greater than 0, there are many values that will satisfy this one. So one such value would have been this one, another such value would have been this one. Now, if you have to if you have to calculate this one further, ln of t has to be equal to negative pi over 2. In other words, e to be negative pi over 2 would have been equal to t. That would be one value which we can look for. Now, then here we realize, does the particle change direction at this moment? Yes. The answer would have been yes, because it cuts across the x-axis. Change of the sign. And find the position and acceleration at this particular moment. Position here becomes s of t is equal to sine of ln of t. Technically, we can put this value in here, or we can put ln of t. Okay, that has to be equal to negative pi over 2 by plugging that here. In this particular case, we could have gotten sine of negative pi over 2, and our answer will be equal to -1. Now, acceleration will be in fact equal to -1 over t squared times cosine of ln of t plus sine of ln of t. Now, as you plugged in negative pi over 2 in these two locations, you will realize that this portion becomes 0 and this portion becomes -1. Hence, our answer becomes 1 over, in place of t, we'll be plugging in e to the negative pi over 2 square plus 0 plus -1. In other words, we'll end up getting 1 over e to the negative pi. In other words, e to the pi becomes our final answer. We'll discuss about more about this question later in class.